So Shami, can you tell me what is the flow of current in a circuit? How does it flow? It is always from positive to negative. But what is the electron flow?
Negative to positive.
But we always take the flow of current is always taken from positive to negative. Okay. What positive to negative? Positive to negative क्या चीज़ है? They are the positive to negative terminals, right? Right?
Yeah.
You're supposed to draw the circuit diagram for a torch which is shown in the circuit in the diagram. So can you draw a circuit quickly? Draw a circuit and show it to me.
Yeah. Should I draw it on the screen?
In your notebook, draw it.
Give it a get a pen once. Sorry. Yeah.
बन गया?
One second. Series was when I guess all the lamps and like whatever thing that was getting powered was in one line and
Okay.
in one flow. So everything was powered in one flow. And in parallel, they were in different sections. So like they were all being powered together at the same time.
Okay. So what the thing that is in front of you right now is the series or parallel?
Series.
Okay. Now we are going to discuss about the series circuit.
Yeah.
Trisha, what do you observe? How does the current change in the circuit? Does the current change at all?
No.
No. So for a series circuit, the current remains the same. Can I say that?
Yeah.
For a series circuit, the current will remain the same. Okay. Then what about the voltage?
I think it'll be different.
The voltage is going to be different. Okay. Suppose this one is the voltage is the rating of the battery. Suppose this is 10 volt. And suppose these are two lamps which are absolutely similar, then this would take 5 volts and this would take 5 volts. Am I clear?
Yeah.
Right? So please note down that in a series circuit, this is a very important point. In a series circuit, the current doesn't change, but the voltage is, the voltage varies. Okay. Now, suppose in this particular circuit, you don't see any switch. Suppose I add a switch to this, what will happen? When I switch this on, what will happen? Will both the bulbs glow at the same time or not?
No.
In this previous circuit, there was no switch. But in this circuit, we added a switch. What will happen to the bulbs when you switch it on?
I guess there'll be a little bit of a delay between the two bulbs.
No, my question is, what will happen to the bulbs? Will they glow or not if I switch it on?
Yeah.
Both? Both? Or
Both.
just one? Both.
Both.
And if I switch it off, what will happen?
Both of them will switch.
Huh? Both of
If
them
you
will
switch,
be
both
switched
of
off.
them will.
Now imagine in your room, you you switch one thing on, and everything in the room, all the lights in the room are glowing. Would you want that all the time? मतलब आपने एक
No.
स्विच ऑन किया और सब कुछ कनेक्ट, पूरा घर उससे कनेक्टेड है, तो will you want that?
No.
It's not advisable. When you're in a certain room, you would want only that room का light on. You would not want कि पूरे घर का light on हो जाए, right? So it's an advantage, but it is a disadvantage as well, because unnecessarily you will be using a lot of energy. So this becomes one of the disadvantages of a series circuit, that if all the lights are in a series, then what will happen when you switch it on, all of them will be switched on. If you switch it off, all of them will be switched on. So you're controlling all the light lamps by just one switch. Some places, yes, we would want it, but we don't want in every house, every room, right? हमारे पास किचन में जाना तो किचन के लिए अलग लाइट होनी चाहिए, वॉशरूम जाना तो वॉशरूम की अलग लाइट होती है, लिविंग रूम है तो लिविंग में अलग होनी चाहिए, right? You can't have one switch for all the rooms, right? So this is one disadvantage of a series circuit, that one switch controls everything. Okay. Now, each component shares the voltage of the power supply. So adding more bulbs in the series what will happen? This is a second disadvantage. If I am, like I said, so here, suppose this was 10 volts. Okay, if this is 10 volts, suppose this is 10 volts, and they are exactly similar lamps, 5 volt and 5 volt, right? Suppose I add one more. So what will happen? Then will it be 5 volt anymore? It will be approximately 3 and 3. So I will write 3.3, 3.3 and 3.3, something like this. Suppose I add one more, एक और add कर दिया bulb, तो क्या हो जाएगा? It will be 10 divided by 4,
2.5.
right? So what? So 2.5, 2.5, 2.5, 2.5. But so what? What will be the effect? The effect will be each of them is not getting enough energy, because voltage nahi mil raha. So what will happen? What is the repercussion of this? The light will become dimmer and dimmer. Their capacity is very high. They can glow very bright, but because you are not able to provide enough energy to them, they will not be able to provide you enough light. They will not be bright. They will become dim. So what is the second disadvantage of a series circuit?
That the voltage will keep splitting between the lamps and the light will get dimmer.
Right. So the light will get dimmer. So two disadvantage. One, that series circuit is being controlled by one switch. And second, that the voltage is distributed. So the more number of bulbs, the dimmer the light will become.
What happens if like there are two different kinds of lamps or like sizes or whatever?
So if there are different sizes, then they in the same ratio, it will be distributed in the same ratio. Suppose this one is we will come to that when this is a smaller resistance, they will be distributed in same ratio.
Right.
So what I am telling you right now is, suppose they are equal, because then you are able to imagine it properly. If they're equal amounts में distribute हो जाएगा. लेकिन अगर equal lamps नहीं है, equal in what sense? Equal in the sense of resistance. अगर equal नहीं है, then they will have the distribution in the ratio of the resistances. Okay? Right? Understood? So parallel circuits करते हैं now. Okay. Now, what did you learn in series circuit? What is the same in the series circuit? What remains same and what changes in terms of current and voltage?
I guess different sectors or something. Current will be
in a series circuit. What remains same and what changes? In terms of voltage changes and current remains the same. But in a parallel circuit, it is absolutely opposite. So यहाँ पर क्या होगा? That each of them gets the same voltage. So if this is suppose 5 volt, now first of all, do you see that this is connected, X and Y are connected in parallel lines?
Yeah.
right? So when it is in parallel lines, what we see is this one gets a 5 volt and this one will also get a 5 volt. So this becomes an advantage of a parallel circuit, that no matter how many bulbs, how many, how many lamps I put in each parallel circuit, each parallel line, it won't matter. Each of them will get the same voltage. So the problem of dimming down, dimmer हो जाता है, brightness की जो problem है, वो problem खत्म हो जाती है in a parallel circuit. Have you understood this? That problem is over. So what is an advantage of a parallel circuit? That each resistance, each component gets the same voltage. Clear? Clear? Next. Second advantage. Now can you see? There are 3 switches, right? For I can put one switch in each and every leg. So if I switch this on, only this one will be on. If I switch this on, only this one will be on. If I switch the third one on, only this one will be on. अगर मैंने इसको off कर दिया तो क्या हुआ? That will become off, but it will not affect the rest of the two. So this becomes an advantage of a parallel circuit. What is the advantage? That you can have individual control in each and every parallel line. So 2 advantages, Shamik, of parallel circuit.
2 advantages: the you can switch them off like separately. So like if you switch one on, all of them won't switch on. And second, the voltage will differ, but I guess
Will the voltage differ?
voltage will be the same
The voltage will be the same.
and current will be different.
Current is going to be different, but what is the advantage? Risha, can you tell me what is the advantage?
Of parallel circuits,
Of parallel circuit, yes.
you can control each parallel line with switches.
Okay. And the second one?
And the voltage doesn't split. It's the same everywhere.
It's the same everywhere. So usse advantage kya hai?
It won't become dim if you add more bulbs.
Yes, the brightness remains the same. There will not be dimming down of the lamps. Is it clear? Shame clear hua?
Yeah.
Advantages and disadvantages.
Hmm.
Okay. Now let's see how the current moves in a parallel circuit. Have a look. Series circuit में हमने क्या देखा था? How was the current moving? Huh?
As
In a series circuit, how was the current? Was it the same all throughout? The current was 3 amperes. Was it the same all throughout? Yes.
Yeah.
Okay. But what do you see here? यहाँ पर क्या हुआ है? It is different. In the main circuit, the current is 5 amperes, right? यहाँ से 5 amperes निकला और यहाँ पे 5 amperes enter किया. लेकिन the moment this came here, अब इसको समझ नहीं आया what to do now when it came here. यहाँ से क्या हुआ? There are 2 sides. Now see, I can see in one leg it is 3 amperes, another leg it is 2 amperes. That means this has a higher resistance. When something has a higher resistance, less current flows through it. So यहाँ पर this one was lower resistance. So equal amount नहीं distribute हुआ इस case में. इस case में depending on how high or how low the resistance is. Shamik, are you listening?
Yeah.
Are you concentrating? Put the phone away. Okay. Lower resistance में यहाँ से आप देख रहे हो कि जब low, if something has low resistance, will more current pass through it or less current?
More current.
More current. You understand what is resistance? Resistance is to stop. To stop something. So
Yeah.
if I am trying to stop any current to pass through me, तो मेरे क्या होगा? Less current will pass through me. If I'm allowing the current to pass through me, तब क्या होगा? I am a good conductor. है ना? Right? So in the same way, if this lamp here that you see, it has a lower resistance, so more current passes through it. This has a higher resistance, so less current is passing through it.
What is
Now,
that?
huh?
What is that? The box.
That is a resistance. That's a symbol for resistance. It can be anything, any kind of resistance. It can be fan, it can be an AC, it can be a fridge, it can be a microwave, anything. Okay. अब आप देख रहे हो कि यहाँ पर हाई रेजिस्टेंस है और यहाँ पर लो रेजिस्टेंस है. सो करंट तो 5 एम्पियर्स ये टोटल, तो उसमें से 3 एम्पियर्स यहाँ चला गया, तो बचा कितना? 2 एम्पियर्स दैट केम हियर. ओके. नाउ व्हाट विल हैपन? इसके थ्रू तो ये 3 amperes यहाँ तक पहुंचा. यहाँ से this 2 amperes came, went like this. After coming here, what will happen? This 3 and 2 will get added again, and when it comes back, it has to come back as full 5 amperes, not as 3 or 2. Clear? जितना करंट यहाँ से निकल रहा है उतना ही करंट यहाँ एंटर करना चाहिए. ठीक है? Maybe on the way it gets distributed. That will depend on how much is the resistance in each one. Is this point is clear? So can I say that the total current through the whole circuit is the sum of the currents through the separate components. So there is one component here, there is another component here. इसके through जितना current गया, इसके through जितना current गया, total current will be the total of that. Correct? Any confusions in this?
No.
What are the advantages of connecting two lamps in parallel rather than series to a power supply? We have discussed this already. When connected in parallel, the lamps are brighter, okay, as compared to series. Second, lamps can be controlled individually with switches. ऐसा नहीं होगा कि आपने एक switch लगाया तो दोनों control हो जाए. Each switch, if you put separate switch for them, आप एक switch से एक को control कर सकते हो. So you can have that kind of control. Understood? Individual control. Okay. Third point, one lamp will continue working if the other is not working, है ना? Because individual control है. अब अगर मैंने यहाँ पर switch लगाया, suppose I put a switch here, I switch it on. अब मुझे सिर्फ ये वाला लैम्प जलाना है. It is possible? Is it possible?
In series.
In series, will it be possible? I just want to switch this one on.
No.
Not possible, right? But in parallel, it is possible.
Yeah.
Now this it says calculate the current measured by the ammeter A1, A2, and A3. You know what is an ammeter?
Yeah.
What is it?
I guess it measures current.
Ammeter is a machine, is an instrument which measures current. Okay, what is an ammeter? It's a machine or an instrument which measures current. How is it connected? You will see it is always connected in series. How is it connected? It's always connected in series. So 2 points about ammeter, always connected in series, and it measures the current.
Isn't this
Okay.
parallel?
Huh?
Isn't this parallel?
And the next point is, what is a voltmeter? Voltmeter is an instrument which measures the voltage. How is it measured? How is it connected? So it is always connected in parallel. So suppose मुझे voltage निकालना है, तो I will connect the voltmeter like this. हर एक के पास मुझे voltmeter को ऐसे connect करना पड़ेगा.
But the ammeter is also in parallel.
Ammeter is in series. आप देख रहे हो ये lamp है और ये resistance है. This is lamp and this is a resistance. अब आप देखो कि कहाँ पे ये lamp के साथ series में लगा हुआ है ना?
अच्छा, so if it's okay, so it's in the same. Okay.
And ये resistance के साथ series में लगा है, right? Right. So whenever you want to connect an ammeter, it is always connected in series. Okay, Trisha? Ammeter is always connected in series. Now, आपको ये बताना है calculate the current measured by ammeter A1. A1 में कितना current होना चाहिए? यहाँ पर 6 लिखा है और यहाँ पर 2 लिखा है. तो यहाँ पे कितना होना चाहिए बेटा? How much should be in A1?
6.
A1.
Oh, wait, no, 2.
2. Okay, Shamik, how much should be in A2?
Oh, what? Sorry, my brother just entered the room.
Huh?
My brother was talking, so I was like talking to him.
What? How much is the current in A2?
4.
4. Because क्या हुआ, यहाँ पर 2 amperes आ गया और यहाँ पर 4 amperes आ गया, and you know that total has to be 6 amperes, right? Okay, now this 2 amperes will go here, this 4 amperes will come here. What will happen at this point? यहाँ पर कितना current होगा?
6.
6 amperes. So how much is A3 going to measure?
6 amperes.
A3 is going to measure 6 amperes. So we have understood this point. Chalo. Trisha, read the first line.
When components are parallel together in series.
Are parallel together in series, मतलब?
Wait. No, when components are connected together in series, they will all have the same current flowing through each of them.
Okay. Shamik, next one.
When components are connected in parallel to each other, they will each have the same voltage.
They will each have the same voltage. Next also, you read.
Lamps are usually connected in dash to each other as this parallel to each other, as this allows them to be controlled individually by switches. And if one lamp
Okay. Trisha, last one you read.
And if one lamp blows, the others can still continue to operate.
If one blows, then the others can still continue to operate. I hope there's no confusion up till here. Right? Now we move to a very, very important topic for today. Okay, Shami का भी phone छोड़ दो बेटा.
Yeah, no, it is.
So this is how a resistor looks like in real life. There are certain bands on this. This is how it's kind of small. अगर आप कभी भी कोई सर्किट देखोगे तो आपको इस तरह का रेजिस्टर नजर आएगा उसके ऊपर, ठीक है? This is a resistor when you especially make a motherboard and all. Motherboard वगैरह कभी देखा है एक लैपटॉप का या so you will see a lot of these resistors put on that motherboard, right? Yeah. So resistance. Now English word resistance. What does it mean? To stop, right? So resistance is opposition. और हम यहाँ पर किसको oppose कर रहे हैं? What are we trying to oppose? What are we trying to oppose? We're trying to oppose the
Voltage?
not the voltage. What did you say? पहले?
Current, no.
Current. We're trying to oppose the current. Correct? So resistance will always try to oppose current. Now, अगर कोई resistance जो है वो इतना कम है that it is not able to oppose, तो हम उस resistance को क्या बोलते हैं? It is a conductor. Low resistance or high conductance. So can I say that they are antonyms of each other? Conductance and resistance.
Yeah.
Resistor and conductor, correct? Right? So copper wire is a good conductor, which means क्या है? What does it mean in terms of resistance?
Bad resistor.
Bad resistor. That means उसका resistance बहुत कम है, right? Right? And okay. Now all devices have some resistance. अब चाहे it can be fan also has resistance, light also has a resistance, AC has a resistance, right? Depending on the thing, आपको हर बारी या तो resistance mention किया होगा या आपको निकालने के लिए बोला जाएगा. उसका symbol you can see it's put in a box like this, a rectangular box. That's the symbol for a resistance. अब हमें पूछा कैसा जाएगा question on this, okay? That we will try to understand. The question that will be asked from us is based on Ohm's law. What is Ohm's law? Ohm's law tells us that voltage is directly proportional to the current. So जितना voltage रहेगा उतना high current रहेगा, but it also अब आपको आप ये देखो mathematically पहले मैं इसको समझाती हूँ. This is a proportionality symbol. In place of this, I need to put an equal to sign. I can't equate things with the proportionality symbol.
Ki.
जब right तो K आता है. So in this case वो K नहीं होगा. In this case it is a constant resistance. एक constant आ जाता है जो हम K लेते थे. तो यहाँ पर ये वही K जो है यहाँ पर R होगा, and this R is nothing but the resistance. And if you actually draw this, so you know that dependent variable is always on which one? Dependent variable has to be here. Independent variable has to be here, right? So your independent variable is always the voltage and dependent variable is always the current. And जब आप इसको draw करोगे, more the voltage, higher will be the current. और जब आप इसको draw करोगे तो उसका जो gradient आएगा, that gradient is nothing but R, which is equal to V upon I. So in this case the gradient 1 upon R आ रहा है क्योंकि हमने I said V upon I आएगा, right? V upon I होगा. So यहाँ पर आपको actually I upon V मिल रहा है and you need to calculate I upon. You need to calculate I upon V because आपको R निकालना है. Is my point clear?
हाँ.
यहाँ पे
So
actually I
is it
upon
E upon I or I upon V?
it is 1 upon R which is I upon V. जब आप actual circuit actual ये बनाओगे, but हमको तो R calculate करना होता है. वो R कैसे निकलेगा? It will be V is equal to V upon I is equal to R. This is how you will calculate. आपको उसको reciprocal करना पड़ेगा. I'll repeat this because it might sound a bit confusing. See, it's very easy that I tell you कि हमको इधर पे voltage रख लो और यहाँ पे current रखो. एक इस पे voltage आ गया, इस पे current आ गया, तो जो gradient बनेगा वो R मिलेगा. ठीक है? This R is V upon I, rise upon run. ठीक है? But problem is when we are actually drawing it, आपको rules follow करने पड़ते हैं, right? And the rule says that you put the dependent variable here on the y-axis and independent variable here. So dependent variable is I and the independent variable is V. तो जब आप इसका gradient निकालने जाओगे तो I upon V होगा क्योंकि x on the y-axis we have I and on the x-axis we have V. So I upon V आएगा and I upon V is not R, it is 1 upon R. फिर आपको उसका reciprocal करके फिर R निकालना होगा. My point is clear or not?
Yes.
Absolutely clear. Shomik, up clear were you on the point?
Yeah, got it.
So what is the formula? Ohm's law is clear. The formula becomes V is equal to IR. It becomes a very, very important formula for us to do all our questions. आपको पता है R has to be measured in ohms, V is measured in volts, I is measured in amperes. R is the resistance, V is the voltage, and I is the current. Clear हो गया हमको ये? चलो फिर आगे बढ़ते हैं. Measuring resistance. First thing, calculate the resistance of a lamp if a voltage of 12 volts causes a current of 3 amperes to flow through the lamp. Calculate the resistance of a lamp if a voltage of 12 volts causes a current of 3 amperes to flow through the lamp. जल्दी बताओ, it's not that big.
Yeah, I know. I sent the answer.
Shamik, बिना units के
There's a unit for resistance.
ohms.
How do you write that?
अच्छा OHMS लिख दो.
Symbol क्या है?
हम्म?
What is the symbol?
उसका symbol अगर आप symbol आप शायद यहाँ पे I don't know if you're able to, symbol is like this omega.
That I won't be able to.
हाँ, so
Right.
just write OHMS ohms.
I
ठीक
did.
है? All right. So 4 ohms is the answer. Question 2. Calculate the resistance of a heater with a voltage of 230 volts causes a current of 200 milliamperes to flow through the heater. Answer in the chat box. So show answer in the chat. Okay, so both of you have two different answers.
Mine's the second answer.
Yours is the second answer. Second answer, you said. That's
Yeah.
not wrong. Previous answer is correct.
Right. Oh, sorry. I was right the first time, but then I did.
You were
some-
right the first time, right? फिर आपने एक zero और add कर दिया उसमें for what? I don't know for what reason.
I got the conversion wrong.
So 230 volts. This I think we have understood. So do I need to do it for? I mean, to show it again? No, not needed, right? Only thing that you have to be mindful of is it is given as milliamperes, right? और हमको milliamperes नहीं चाहिए, हमको amperes चाहिए, right? Voltage. Quickly, orally कर दो इसको. Shamik, इसका आंसर मुझे बताओ जल्दी. Orally. Calculate the voltage across a resistance of 40 ohms when a current of 5 amperes is flowing. 40 ohms when a current of 5 amperes is flowing. Unmute and speak.
200 volts.
200. Visha, orally.
Is it 12 upon 8?
12 upon 8, which is 1.5 amperes, right? Okay. The graph now. As I said, what do you think will happen here? See, the dependent variable is kept where? Dependent variable is on the y-axis. What is the dependent variable? It's always the current. What is the independent variable? It is the voltage. क्यों independent है ये? Because voltage comes from the battery. और जब बैटरी आएगा, आपने जितना बैटरी लगाया जितने वोल्टेज का, that is independent. It depends on you, that nothing else. But the current which is being produced, that depends on that battery. That is why current is a dependent variable, hence put on the y-axis, and voltage is an independent variable. That's why it's put on the x-axis. अब जब हम यहाँ पर, आप खुद सोच के बताओ मुझे कि जब आप यहाँ का ग्रेडियंट निकालोगे तो यहाँ चेंज इन y हमेशा क्या मिलेगा? हमको डेल्टा I मिलेगा, राइट? और यहाँ चेंज इन x हमको क्या मिलेगा? डेल्टा V मिलेगा. So the gradient would become I upon V, and I upon V is not R. I upon V is 1 upon R. So बहुत ध्यान से, ये मिस्टेक बहुत बच्चे करते हैं. They forget and they write this as R, but यहाँ gradient हमको I upon V मिल रहा है, not V upon I. इसलिए अगर जब भी हम ये कैलकुलेट करेंगे तो हमको हमेशा क्या करना होगा? रेसिप्रोकल करना होगा. Keep that in mind. ठीक है? Keep that in mind. And also sometimes, just to confuse you, the examiner can do something else. The examiner may change this to V and change this to I. In that case, gradient क्या मिलेगा? Change in V upon change in I. So that means it is R then in that case. ठीक है? So be very mindful कि graph क्या दिया है. Definitely check what is on X and Y axis and then decide your gradient. Clear hai? Okay. Now another important point, the current voltage graph of a wire or a fixed resistor at a constant temperature. Now यहाँ पर हमने ये जो निकाला था fixed resistor, because that R is going to be constant, right? R में change नहीं आएगा. अब gradient कभी change नहीं होता, correct? For a straight line. So R is not going to change. Now इसके साथ एक चीज और लिखा है, constant temperature. What does it mean? This means that you cannot change the temperature much. ज़्यादा change नहीं है, 2-4 degree is okay. You cannot have much change in temperature, because अगर वो change हुआ तो elements start behaving differently at a high temperature. So there will be a change in the current, and hence the resistance will not remain a straight line. वो एक curve बनना start हो जाएगा. So बहुत ही ज़्यादा important, जब आप ये statement लिखोगे, this is a very important thing to be written. Is it clear? Clear, Trisha, also?
Yeah.
Okay. और इस ग्राफ को बनाने के लिए ये पूरा सेटअप क्रिएट किया जाता है, and this setup is the experiment for Ohm's law, जहां पर there is a cell, there is a variable resistor, there is a switch, there is a resistor, there is a ammeter, and there is a voltmeter. Okay. Now, अब question आएगा, why do you need a variable resistor when you already have a resistor? Why do you need a variable resistor when you already have a resistor? तो इसका आंसर कैसे करना है? ये variable resistor क्या कर रहा है, आप समझ रहे हो? The variable resistor is used to apply a range of voltage across the resistor. Mainly, हम इस resistor का R निकालते हैं. ठीक है? What are we trying to find out? We are finding the R for this resistor. Hence, इसके पास A भी connected है और B भी connected है. बात समझ आई? तो फिर इसका क्या काम है? इसका काम है यहाँ से इसके पाथ में रेजिस्टेंस क्रिएट करना, so that we can vary the voltage. और जब vary the voltage होगा तो करंट वेरी करेगा. इस रेजिस्टर का क्या काम है? वेरिएबल रेजिस्टर का. Why have you put it here?
To vary the voltage.
Yes.
So that,
one way is that you keep changing the battery. Another way is keep the same battery, keep the same cell, and put a variable resistor. Resistor को vary किया तो automatically current will change in that cell. The voltage will change and hence the current will change. बात समझ आई? ठीक है? So now what will happen? You make this whole this table, voltage 0, voltage is 0.3, 0.69, 1.2 and 1.5. And the current across will also be, it will be measured in A, voltage is being measured in B, correct? And if you observe, B is connected parallel to the resistor and A is connected in series with the resistor. Clear? And this is the circuit that you get. The wire or resistor obeys Ohm's law, which states that the current is proportional to the voltage. Okay? Clear? Now, chalo. So start.
The electric current will only flow around a circuit if there is no gaps in the circuit.
Okay. Shamik?
All components have
Resistance.
resistance.
Continue the next line.
Greater the resistance, the smaller is the current.
Correct. For the same applied voltage. Trisha?
A current voltage graph.
No, resistance is measured
Resistance is measured in ohms.
in ohms. Next line also.
A current voltage graph for a resistor is a straight line throughout the origin.
Okay. Shamik?
This shows that the current through the resistor is proportional to the applied voltage.
Now comes a filament. Okay. Now see. Resistance of a filament lamp increases as the. Can you see this is not a straight line?
Yeah, it's different.
What does it show? What does it mean? That
resistance is changing as the temperature is increasing.
As the temperature is increasing. And आपको पता है कि bulb का filament काफी गर्म हो जाता है. Have you ever touched a bulb? It becomes really hot. So can I say that the filament is not obeying the Ohm's law? Yes, because अगर obey करता, then you would have got a straight line, which you are not getting here, correct?
Right.
Right. Perfect. So this part is clear. Here, as the temperature is increasing, the resistance of the filament is also increasing. Temperature increases, resistance increases. Reversing the voltage, अगर हमने reverse कर दिया voltage को, उल्टा कर दिया, battery को उल्टा लगा दिया. Reversing the voltage, negative values in the graphs reverses the direction of the electric current but does not change the shape of the curve. So if you observe, suppose आपको मैं अभी पहले initially, let me just hide this part. ठीक है, ये part अभी नहीं है. हमें किस तरह curve दिख रहा है? It's a curve, right? We see that it's a curve, not a straight line. Doesn't obey the Ohm's law. So what is happening here is it is not obeying the Ohm's law because the current and voltage are not proportional, right? What if I change the battery? We reverse the battery. If we reverse the battery, then also there is no change in the curve. The curve still remains. It's just the current का direction change हो जाता है, इसलिए सब कुछ as it is वो S जैसा उल्टा में नजर आता है. Clear हुआ हमको? Right? Right? Okay. Now look at the diagram of a diode. यहाँ क्या हो रहा है? Diode में क्या दिख रहा है आपको? Just tell me your observations.
The diode has a very high resistance in the reverse direction.
Okay, so current only flows through the diode in one direction. आपको ये दिख रहा है कि एक ही direction में जा रहा है. इस direction में तो जा ही नहीं रहा. यहाँ पे it's all zero up till here. और यहाँ से आने के बाद ये ऊपर की तरफ गया. Which means ये जो diode है, ये क्या कर रहा है? हमेशा ध्यान रखना है. Diode का डायरेक्शन आप रिवर्स नहीं कर सकते. अगर आपने डायरेक्शन रिवर्स किया, डायोड विल स्टॉप वर्किंग. So diode has a very high resistance in reverse direction, so it will not allow any current to flow. Whereas this diode is allowing the current to flow in this direction. ऐसे जाने दे रहा है. तो एक पॉइंट के बाद तो वो कौन सा डायरेक्शन, हाउ डू आई रिमेंबर? सो यू सी द डायोड सिंबल इज लाइक दिस. ये सिंबल होता है. सो जहां पर एरो है, ये उसी डायरेक्शन में करंट को अलाउ करता है. अगर आपने इसको उल्टा करा, तो सपोज आपने इसको ऐसे करके कनेक्ट किया, तो आपने पहले ही स्टॉप कर दिया है. So the current will not flow through it. Clear हुआ?
Right.
So
What
you
is
cannot? हाँ.
reverse direction मतलब like क्या?
Reverse मतलब मेरा पहले डायोड ना ऐसे लगा हुआ था. नाउ मैंने इस डायोड को और यहाँ से कुछ और कनेक्टेड था. सपोज एक लैम्प कनेक्टेड था. अब मैंने क्या किया, इस डायोड को उल्टा कर दिया like this, and now I am connecting the lamp. This will not work because you have reversed the direction, so it won't work. ठीक है, समझ आया? And what are LEDs? They are light emitting diode, or they also function the same way. And इनके ऊपर सिर्फ because they are light emitting, so you show that with an arrow. Clear? Now there is a thermistor. Thermistor. Therm is what? Heat. And ester comes from resistor. So thermistor. So the resistance of a thermistor decreases as the temperature increases. ये एक ऐसा स्पेशल काइंड ऑफ रेजिस्टेंस है जिसका टेम्परेचर बढ़ाओगे तो रेजिस्टेंस कम होगा. ठीक है, और यही हमारे किस में यूज होता है, कहाँ यूज होता है, क्या लगता है आपको कहाँ यूज करते हैं इसको? These days you have those digital thermometers.
हाँ.
वो कैसे वर्क करते हैं? बुखार होता है तो टेम्परेचर बढ़ता है, और जब टेम्परेचर बढ़ता है तो थर्मिस्टर जो है वो अलाउ करने लगता है, उसका रेजिस्टेंस कम हो जाता है, तो वो करंट को अलाउ करता है फ्लो करने के लिए, और वो जितनी देर तक के लिए अलाउ करता है आपका टेम्परेचर रीडिंग उसी से आता है. बात समझ आई? राइट? अंडरस्टूड? ओके. सो द रेजिस्टेंस ऑफ अ थर्मिस्टर डिक्रीजेस as the temperature increases. ये जो चीज मैं बता रही हूँ, this is very important to remember. Higher temperature line therefore has a greater slope than the lower temperature. So, अगर मैं आप खुद सोच के देखो कि if this is at 50 degrees and this is at 30 degrees, तो क्या मतलब, what is it showing? This has a higher gradient. This has a higher gradient, but ये gradient किसका है? 1/r का है. यानी कि एक्चुअली R तो स्मॉल हो गया इस केस में, तो ज्यादा टेम्परेचर पे R स्मॉल हो गया. यहाँ पर ये ग्रेडियंट 1/r बन रहा है, और ये ग्रेडियंट नीचे की तरफ है. इसका मतलब R इस केस में ग्रेटर होगा, बिकॉज हायर लोअर टेम्परेचर मोर रेजिस्टेंस, हायर टेम्परेचर लेस रेजिस्टेंस. इज दैट क्लियर त्रिशा, शौमिक?
Yeah.
अब आते हैं LDR. LDR is light dependent resistor. What is it?
Light dependent resistor.
Light dependent resistor. Light dependent resistor. Now, जैसे thermistor था, it was temperature dependent. This is what dependent? Light dependent. What will happen here? Light dependent resistor decreases as the intensity of light increases. So, what will happen?
The environment, I guess, is the lesser the resistance.
हाँ, so अगर morning का time होगा और अगर night का time होगा, तो we can say that light dependent resistor जब ज़्यादा light है, so बहुत light है, तो वहाँ पर क्या होगा? The resistance decreases, so which means it is brighter, correct? And the resistance increases, that means it is going to be dim. Clear? इसका कहाँ यूज होता है? ट्रैफिक सिग्नल.
Traffic.
ठीक है, उस पे जो रेड लाइट होता है, ग्रीन लाइट होता है, येलो लाइट होता है, दे आर ऑल मेड अप ऑफ LEDs, लाइट डिपेंडेंट रेजिस्टर्स. ठीक है.
रात को ऑन नहीं होता है,
हाँ,
रात को ऑफ होता है.
नहीं ऑफ नहीं होता है, बट उनको यूज 2-3 रीजन से उनको यूज किया जाता है. वन, दे डोंट नीड अ लॉट ऑफ पावर सप्लाई, सो एनर्जी सेविंग के पॉइंट ऑफ व्यू से. एंड लाइट डिपेंडेंट है, तो मॉर्निंग में क्योंकि ऑलरेडी ब्राइट है, तो आप क्या चाहते हो कि आपको लाइट भी ज्यादा ब्राइटली नजर आए ना. अगर डिम लाइट होगी तो आपको दिखाई नहीं देगा.
अच्छा.
रात को तो अंधेरे में आपको डिम लाइट भी दिखाई दे जाएगा. करेक्ट.
Okay. So it dims as the night comes.
एज द नाइट कम्स, तो डिम भी हो गया तो कोई दिक्कत नहीं है, बट मॉर्निंग में क्या होगा.
हाँ.
पर अगर वो डिम होगा तो आपको नजर ही नहीं आएगी लाइट.
Right, right.
So that here we use a light dependent resistor. Clear? ठीक है. So take this as a homework, please. When is the school reopening for you, Shamik?
July 7th.